Well, hello, everyone. Thank you for joining us once again on Did You Know, the ESCO HVAC Show. So, we've got a lot of fun to do today. So, we're actually going to do more of a hands on demonstration as well as some education on working on aluminum, especially on aluminum coils. Because as we start seeing a lot of new materials being utilized in our industry, one of them that we're seeing is a lot more aluminum evaporator and condenser coils, right? A lot less copper. But what happens when you've got problems with those? Well, now we've got things that we got to work on. And a lot of people are very leery of working on aluminum. So today we're being joined by Bob Cristan. Bob, how are you, sir?
Very good. Thank you.
Otherwise known as Bob the Brazer from Lucas-Milhaupt. All right. So we're going to spend a little bit of time studying about aluminum today. And so, Bob, let's talk a little bit about some of the challenges that you see as an educator in brazing when we're transitioning from being comfortable working on copper to working on aluminum. Because many of us educators were technicians while we're out in the field. So we may be very comfortable and very experienced working on copper, but aluminum is an entirely different animal. And many of us are a little leery of it. And yeah, definitely everyone let us know where you're joining in. Todd, you're joining in from California. Bob, you're as well in California. Where are you from?
Sierra Madre, California.
Excellent. And I'm joining in from Brownsburg, Indiana, just outside of Indianapolis. So yeah, let's talk about the differences of going from copper to aluminum. I know you spent a lot of time talking about brazing techniques. And for those of us that are uncomfortable with it, it's probably because we just don't know exactly what the differences are.
I believe what's really has happened is that people look at aluminum as a foreign substance of some sorts.
Yes.
And because of they're very comfortable with copper, they don't want to transition to aluminum. But like I've told everybody I deal with is that, we don't have any say or control over the products that are out there. What we have to do is accommodate ourselves to whatever's there and get comfortable using those products. So with the transition now to aluminum, the biggest concern for most people is that they feel it's not repairable.
Right.
And it's totally wrong. Lucas-Milhaupt developed a product about 7 or 8 years ago and has been on the market for quite some time. It's called ALA22.
Right.
It's basically what it is. It's a zinc aluminum rod with the flux on the inside of the rod, and it will repair aluminum, be it your conventional coil or your microchannel.
Microchannel as well?
Yes.
Oh. Okay. That's interesting.
And that same product will also join copper to aluminum. So anybody that's out there doing an install of an aluminum coil, that at some point there's going to be a transition to copper. And oftentimes that's where the issue would be, is that transition joint. But the properties of aluminum are very similar and sometimes even better than copper as far as heat transfer is concerned. So there's no loss there at all. The bigger advantage when they first came into the market was that with the advent of the higher SEER products, the units were getting larger.
Yes.
And now if you incorporate aluminum to take away the copper, now the weight is gone down. And now with the advent of the microchannel condenser, the microchannel condenser is smaller as well. So the weight is reduced, but the heat transfer comparison is virtually the same, if not even better, with aluminum. Okay. So now what we have to do is how do you work with it?
Yeah, that's the biggie. Well, I was just at a distributor this morning, and they had a piece of equipment. It was a brand new piece of equipment, got delivered to the contractor, and somewhere along shipping, it had one of the screws from one of the top covers actually get into the coil. Of course, lost its refrigerant, and then they had a brand new unit that had a hole in the aluminum condenser. And so the instructor at the distributorship was looking at me going, "So do I order a new coil? Even if I do, I'm still going to have to work with aluminum. I'm still going to have to do some brazing, or can I just fix this?" I said, "Well, you need to join us today. You need to hop on the show." So hopefully they'll be there. Fred from Missouri. We got George, Western Kentucky. Howard's out in Denver. We got Todd in California. We got Hendrick over in Chicago, David Harrell, Cincinnati. Thank you all for joining us. Quite a few people out there in the audience, too, I can see haven't told us where you're from, and that's all right. We just always like to know how large this community is growing. So when we start talking about repairing of coils, Bob, I think it's going to be very important to be able to make repairs, because you and I had a conversation earlier about the amount of technicians, particularly, that encounter problems with aluminum coils and do not make an attempt to repair them. They go immediate to replacement. And I think it's exactly this topic, is that there's this stigma that aluminum is difficult to repair, and that it doesn't appear to be the truth.
No, by no means. There's a couple of key things when we're heating that we have to be cognizant of, which we'll walk you through today, and the alloy and how to use it, and its relationship between the melting point of the alloy and the melting point of the aluminum itself.
Okay. So is there a significant difference in those melting points?
Well, the rod itself, the AL822, flows at a temperature about 900 degrees. Okay. The aluminum itself will melt at 1218 degrees. So our window is only 300 degrees.
Okay.
Now, when you're looking at copper's window is 500 degrees. The alloy, a 15% alloy, will flow at 1475, but the copper melts at 1981. But the key with copper is that you get a dull cherry red as you begin to heat. And when you see the dull cherry red, that's an indication of 1475. That's your perfect temperature you want to be at. Unfortunately, though, when you're looking at aluminum doesn't change colors as you heat it. So our temperature indicator will be the rod itself.
Okay.
So we'll apply the heat, and what we do is we'll continually take the rod and tap the surface with the tip of the rod. And the reason we tap with the tip is because this is a flux cord product, and we need to activate that flux first.
Okay.
So a lot of people have a tendency thinking this is like a 15% rod. I can lay it on the side.
Yeah, just leave it there.
It has to hit the surface with the tip. And as you're testing the surface to achieve that 900 degrees, as it begins to flow, and you'll see that, at that point, now the heat will be pulled further away so that we don't quickly jump to the 1200 degrees and then melt the aluminum. Because that's, if you talk to anybody that's made it an attempt at a repair that doesn't understand aluminum or the rod itself, their first attempt, probably 99% of the time, will be that the aluminum melts, because there's no indication that it will melt.
Right. There's no visual to recognize what's actually happening.
Exactly. And then they go, oh no, I melted. And now that hole that was quite small is now quite large and may not even be repairable. So that's where I think the stigma comes in, that people think that it's not repairable because it so easily melts. And yes, it does. But again, if you understand the difference between the rod itself and the base metal, the aluminum, you should be fine.
So another one of those almost a stigma that comes through is people say, "Hey, Ty, thanks for joining us." Yeah. Now, come on. Everyone out here is probably going to raise their hand right now and go, "Okay, I blew a hole through the first time I tried." I know it wasn't just the first. It was probably the first, the second. And being that I only got 3 out of my first 10 tries successful, I blew quite a few holes on those first few times. But the thing that we get the questions about is, well, what should I be teaching it on? Because isn't a oxygen acetylene torch too hot to be working on aluminum? Is that true?
Well, it is too hot. I mean, the torch itself will deliver close to 4,700 degrees.
Right.
Which, if you think about it, it's more than enough to melt copper as well.
No, so true.
It's how we use the torch and the flame itself that allows us to still use it for an aluminum application.
Yeah, Murph, you're right. If you're lying if you're saying you haven't burned through aluminum when you tried. So the goal here, Bob, is to be able to help educators. I see a lot of educators out here joining us today, and many of us struggle with implementing this into our classroom, and it's vital that we teach this. I believe personally we're going to see a lot more repairs on aluminum R410A coils in the next couple of years. The primary reason is as our manufacturers are converting their lines over to R32 and R454B products, we're going to have less of a supply of R410A coils unless they have been certified to work with A1s and A2L refrigerants as well. And so we're hoping that we can convince everyone to spend more time educating on the proper installation and repair of aluminum in the classrooms, as well as our technicians that are in the field getting a better understanding of what to do for best practices. Because I believe the reason that we shy away from repairing really comes down to just a lack of education.
That's all it is.
Yeah. Okay. So we're gonna do a little bit of hands-on today. And so, Bob, you're actually going to be doing oxygen and acetylene.
Correct.
I am going to take a slightly different route, and we're going to do some exploration. So I'm actually set up in the lab here as well. We both have aluminum coils. I'm going to be working with a micro torch. So I'm going to be working with a slightly smaller setup that still produces more than enough heat. I'm going to be working with a MAP and oxygen mini torch. And we're going to see what we can do with both of them, because both of them actually have excessive heat. And we were talking earlier, Bob, what was the amount of heat off from a MAP gas?
MAP is 2,200 degrees.
And then acetylene,
4,700 degrees.
Right. Okay. So both of them have enough.
The other option would be air acetylene.
Turbo torch.
People are more comfortable with saying turbo torch than saying air acetylene.
Exactly. Okay.
About 2,700 degrees.
Okay. So
but the other option is still to use the straight MAP.
Yep.
Aluminum or even propane. If you drop down to propane, the blue bottle, that's 1,800 degrees. Still enough. The drawback of either MAP or propane is that when you use those tips, typically the tip on those torches are relatively large, and that flame will spread out further than you want to, and then there's a chance of damaging something you're not trying to repair.
Sure, absolutely.
So
that makes sense.
Even with the oxyacetylene, I'm going to show you how to use just the tip of the flame, which then you can concentrate just onto the area you want to repair.
Okay. So where do we begin? So I'm an instructor or I'm a technician, and I'm walking up to a coil, and I don't know where to begin.
Well, the first thing obviously is to find the leak, which sometimes can even be more troublesome and time consuming than the actual repair itself.
Sure.
And what I always focus on is if you're going to take the time to find and isolate where that leak is, if you've done that much, there's no reason why you can't make that repair as well. So once you have found that leak and you've isolated to where it is, the joint area or the leak area needs to be cleaned.
Okay.
We suggest a stainless steel wire brush.
Okay.
Now, I have a coil here that just has numerous holes in it. And what I'll do is I'll just pick one here. Okay. And I'll clean it extensively with stainless steel wire brush.
I'll do the same.
If you have a coil that's an older coil and there's a great deal of dirt on it, you're going to have to clean it. There are cleaners out there that can be purchased. Just make sure that if you do, it's a non-flammable version. They make flammable and non-flammable cleaners, aerosol cleaners.
Okay.
That work very well, but make sure that obviously if you put a torch flame onto here, you don't want a flammable liquid onto that surface.
Yeah, absolutely.
And that will work just fine.
All right. So I've got a variety of joints that I'll be experimenting with myself here. So I have a hole that would represent a screw being popped through. Yep, good point. Absolutely. We want to go back to our soap bubbles, Robert. So once we've located, hi, Mr. Tebby. Thank you for joining us, sir. So once we've located, we got things good and clean, recommended with a stainless steel wire brush.
Okay. The next step will be bringing the torch into play, and I'll be using an oxyacetylene torch.
Okay.
And your settings for the oxygen and acetylene should be 5 on the acetylene and 10 on the oxygen.
Okay. 5 and 10. Now, the only downfall that I have found with using one of these little micro torches is that they are assuming tank pressure, and there's not a regulator with a pressure setting on them. So
Okay.
that is one of the issues that I have found with using this particular mini torch that I had found. But I've found that I can regulate, just not as easily as having a good gauge set.
Okay. But 5 and 10 with oxyacetylene is the key that you're looking for. And that number stays consistent even when doing a copper joint as well.
Sure.
5 and 10. And any medium duty torch to a joint up to probably 1.125 inches.
Okay.
10 would work. The other key thing that's important, and this is where a lot of people are lacking, is when they're brazing, whether it be aluminum or a copper, is their tendency is always to use the same tip. Okay.
True. Yeah.
And typically most of them will use a larger tip because they think more is always better. But it's not the case even for copper. Okay. So right now what I'm using is a 00 tip on my oxygen acetylene torch. Okay. And this would still braze copper up to probably 3/8. Relatively small flame, but you'll see. So if you're going to use the oxyacetylene, we really suggest that you go with the 00 tip. Okay. So the next step would be lighting. Okay. So I'm going to light my torch. Typically, I open the acetylene until I get a clean flame, and then I open up my oxygen, and I pull it back to what we call the reducing flame. And that's what the reducing flame would look like. Okay. Now, the is this long, okay? But when I heat the copper, I'm going to only be using the tip of the flame.
Oh, okay.
Because what happens in a copper application, you'd want to be right here.
Yeah, real close to the heat.
But we're not. So I'll bring in the flame, and if you'll notice, I'm going to heat with just the tip. And then what I'll do is occasionally I'm going to bring in the rod and continually test the surface, because remember, there's no color change here to the aluminum. That's going to imply that it's either too hot or too cold.
Okay.
I'm going to continue doing that. And when we get close, you'll see. What you don't want to do is park the rod over that and not touch, because then the flame will melt the rod. Okay, you see the surface now is accepting the alloy. I pull the flame a little bit further back. And I'm done.
What?
It's that simple.
Okay. Are you ready to instruct me through this?
Okay, let's walk it through.
All right. So I'm going to go ahead and bring in this other one. I'm going to magnify it a little bit and see if I can clean this up a little. And I will bring you and I over here to the side, or I'll leave us right here at the bottom. Oh, that's pretty good. That's clear enough. Yeah. All right. So let me get our rod out first real quick. And we're going to be using Lucas-Milhaupt AL822, which is our flux cord aluminum rod.
So if everybody wants to know a little bit about the rod itself, what it is, it's a thin aluminum rod. And in theory, you could repair aluminum with an aluminum rod, but they both have to melt at the same temperature.
Sure.
So what Lucas came up with is, well, we'll add zinc to this rod, which now lowers that melting point by 300 degrees.
Oh, absolutely.
Okay. Then we insert, this is like a pixie stick, and there's a powdered flux on the inside of the rod. Okay. That's why we always say that we want to touch it with the tip, because we want to activate that flux first.
Okay. And so I'm going to be going in at perpendicular to my surface.
Right.
Okay.
And touching it with the tip of the rod.
Right. Now don't be a bit surprised if I blow a hole in it. This is the new torch, so there's a really good chance that I could on this one. All right, everybody? All right, here we go.
And a lot of people don't want to take the extra effort to do the cleaning. So we can't emphasize enough that you need to clean that surface and remove any dirt. Now, sometimes the case is that you'll have oil present. And as you're heating, that oil might want to come out of that opening, okay? So the trick, or the key that I've run into there, is that if you put that coil under a vacuum while you're brazing, you'll be pulling that oil away from the leak area and allow you to then heat and apply the alloy without it being mixed with the oil present into that coil.
Okay.
So keep that in mind too, a little trick there. But again, Whatever it takes to clean, please clean.
All right, let's try this again with the torch up closer so my hoses aren't too short. Okay, so I've got a cone of about, this is actually around 3/8 of an inch of a cone. My tail is about 4 inches long. Now, am I going to be working the heat directly into, like if I'm working on a hole, am I going to be working around it or directly in the center?
The center is fine. What happens if you continually move the flame around, you're moving it in and out of the area that you're trying to heat. So if you keep the heat constant and just using the tip, and then keep testing the surface with the rod. Don't be afraid to keep trying, because again, there's no indication that it's going to flow until you actually see the rod. Okay.
Oh, yep.
So you're melting the rod with the flame. Remember, the surface of the aluminum is what's going to melt. So you're not quite hot enough yet.
Now, do I remove my rod once I have enough?
I can't quite see the opening now. Okay.
I lost it.
Your surface isn't hot enough.
Okay.
So what was happening is that your rod was being melted by the flame, not the surface temperature.
Not the surface. So should I move my heat away from the surface slightly?
Only once the rod begins to flow. Okay. See it coming there? Okay. Now just apply the heat, and you can feather that out a little bit.
Oh, look at that.
There you go.
Look at that. Are you kidding me?
What people do is they get anxious. What they have to do is just wait for that surface temperature to melt the rod. And what happens is they'll put the rod into the flame. Well, then the flame melts the rod.
Yeah.
It doesn't catch.
Yeah.
That's the big key right there.
Oh my goodness. I am absolutely impressed with that. And Todd, yeah, that wasn't bad as long as I got my hoses, down to where they need to be and I didn't blow my tank off. All right, so let's try a couple different items here. So I have already prepped this thinking, okay, so what if we have a hole from a puncture, right? We just successfully repaired a hole from a puncture. What if we have a break on a line? So let's try a different style repair now. So let's move over to a different surface. I'm going to go ahead and put my gloves on just because I know that coil is going to have some residual heat in different places around it. Thank you to Tom Cena. We appreciate you joining us today. Glad to have everyone here today. There's a lot of people out there, and we're so grateful to have you joining us. The whole goal is to have top educators from the industry every single week so that we can address pertinent items like this. We know that we're going to see a lot more aluminum coils. So we have to get comfortable working on those, right? Hey, from the UK, Jamie, thanks for joining us out in Cambridge. All right. I was telling Bob, we never know who's going to be joining every week because we have people that are wanting to learn these things all over the world.
Probably wherever you are.
We're all going to encounter aluminum. All right, so let's go back to the drawing board here. Okay. We're going to introduce some oxygen. And by the way, for those that are interested, this is just an inexpensive torch set that I found off from Amazon. And we are running off from MAP gas as well as oxygen purchased at my local Ace Hardware. Nice thing about using a small torch for doing repairs is if I run out of oxygen acetylene from a larger torch, I have to go back to a shop and find some, right? Well, with a smaller torch set, I can actually run over to my local hardware store and gather that. A lot of great people out here. Phil, thank you so much for joining us. So we're going to have you on the show here in no time, Mr. Rains. All right, so let's grab one that is on an exposed area. I just realized I used my little jeweler's.
Start touching with the rod.
Oh, look at
you. Go.
You got to be kidding me.
It's the key to always touch that surface, okay? Remember, the rod is what tells us we're at 900 degrees.
Right.
So if you continually touch and then it begins to flow, then you pull that heat away. Your timing was perfect on that.
Okay, so now we're going to try a crack on a manifold. That's a pretty common place. I'm a little nervous about this one.
This has already been cleaned, correct?
Yes, I did clean it earlier.
Okay. We don't want to not emphasize that.
Well, I think I got it. There we go. Now I can move it around.
Right. If you see you have a pile there, you can move it with the flame.
And so I have two thicknesses here. So it's going to take obviously more heat over on the manifold side. And there it goes. Look at that. I'm sold.
After the joint is done and cool, it should also be cleaned. Wet rag.
And then clean afterwards.
You want to remove excess flux that might be on that surface.
Yeah.
When it cools, it looks clean, but there will still be flux there. We want to remove that.
On the outside of it. Jamie, I'm telling you, it is this easy, man. You got to get you some and go back and spend some time with all of this instruction from Bob. This is why we do these classes. I'm telling you, I was not comfortable doing aluminum. My first 10 tries, I had 7 failures and not bad at all. And no, Mark, with the AL822 rod, it has flux in the core. And that was the point that Bob was making, is that as we are dabbing that surface perpendicular to our surface, we're actually introducing flux out of the core of it. And I don't think I could magnify that enough. But that's what we're doing, is we're using the flux out of the core to be able to make that happen. All right, I have one more. Now, this one's really going to be an interesting one because I've not attempted this before, so I don't even know how well it will work. So let's look at another one. I'm telling you, I promise, Todd, I had not done this before. Like, it's been a while since I have messed with aluminum, and I'm talking years since I've messed with aluminum. But Bob and I prepped before this, giving me a little conversation about this. He was my coach, and I'm telling you, Mark, same. First time I blew a hole right on through, and it was just junk. So I just went and got this coil today, just cut it up today. This is all from a donated coil from my local Johnstone supply that had a damaged coil. I told them I was doing an aluminum class, and they were like, well, boy, we'd really like to see that. I'm like, well, that's why we're doing this. And I've got Bob the Brazer here with me, showing me how to do this. These are the kind of classes you want to join. All right, I'm going to put my gloves on again because I know that I'm going to have some heat on this coil. And let's go for a really, really difficult one. And there has been no guarantees on this particular one, Bob.
Okay.
So we've all encountered a leak in the middle of an evaporator before, right? Okay, I actually had one time. I had a dart got thrown into it.
Well, here now, your leak is in that tube inside the fin there.
Am I going to melt all of my aluminum around it? Typically, I separate my fins out as far as I can.
Try to pull the fin area away from the leak area.
All right. So that would have been the typical procedure in the field, would be to separate my fins. Yes, we're going to lose some fins. We're probably not going to get them back into position when we're done, but I would rather lose a little bit of heat transfer versus losing a coil. Because if I could fix this on site versus having to leave my customer without while I'm waiting for a new coil, I'm at least going to want to give it a try. But I will tell you that in the past, I would not want to have tried this at all. But as I'm getting more comfortable, I'm interested in trying this. I'll get that adjusted a little bit better. This is a manual camera, so I want to make sure. Okay, there we go. All right, so we have a pretty good size hole in the middle of a coil. Now, should I use any less heat or just keep it about the same that I had before?
Same. It's about the same. Again, you want to continually touch the surface with the rod to tell you where you're at.
All right. Here we go. Okay. A little nervous on this one. All right. Once again, approximately a 3/8 inch cone, about 4 inches of tail. And I know I'm probably going to roast some of this thin aluminum at first, but we're going to see what we can do.
Let's start touching. That's going to go.
Oh, you got to be kidding me. No, I think yep, there. Okay. Well, probably didn't get the bottom of that tubing hot enough at that point. But, oh, there it's starting to melt for me to go. Now I'm moving it.
There you go.
Look at that. Okay. Mr. Cristan, you have changed my perspective on repairing aluminum in a variety of different applications. Think about that, Ty. In the past, I have been very leery to approach aluminum the same way I approach copper. I love working on copper. I've gotten pretty good over the years. Didn't think I would be near that with aluminum. So the flux on the rod, that is a good question. And there's not a lot of flux in the middle of that. It's a pretty small core, I would imagine. But like any time we do a repair, we're taking chances of getting debris inside of a system. So of course, the larger the hole, the larger opportunity, just like if it was a copper. But at least we have the opportunity to work on it to see if we can get it closed in. And if you noticed, as I was bringing that rod in, the amount of flux that did get introduced into the copper seemed to dissipate out pretty easily, pretty quickly. And probably because, Bob, what I would assume with its lower boiling temperature, it's probably rising to the surface.
Well, what happens is the flux has a lower melting point than the rod.
Yes.
That's why we touch it first. It activates the flux. Remember what flux does too. This is what a lot of people don't know. Flux removes oxide from the surface, whether it be copper or aluminum.
Yes.
So you're basically applying that flux. It clears the oxide off the surface, and then the alloy melts right behind it to attach.
I gotcha. Mark, no, I'm actually, this one right now is in atmospheric. This is just a cut open piece of coil that I have. I typically don't use any vacuum while I'm brazing. I'm wanting to fill it in at its ambient condition. So no, there was no vacuuming on this. It flowed that easily. No, you're welcome, George. Isn't that, I'm telling you, I didn't have a lot of confidence in myself before we came into the class. So I hope that you take advantage of this opportunity yourself. Yeah, Greg. Seriously, this is just a torch with MAP gas and oxygen and the 822 rod. That's all it is. Nothing special. It's just a coil. Let me grab my. And this is not a pre-made video. You've all seen this all right in front of us. This is, I'll bring up a bigger picture so we can see that. I'll use the other camera. So this is a piece of a 4-ton evaporator coil. All I did was I just took the coil outside, chopped it off because I wanted to be able to do the repairs in the most common places. Pinholes on the exterior that would have been close to, to the fins, to the actual sheet metal of the cabinet, or cracks in manifolds, like we have seen many a times, or something that had rubbed into the surface of the coil. And all three of those scenarios were incredibly easy to do. So, yeah, I'm digging this very, very well.
The other thing we ought to keep in mind too is that with the same rod, the ALA-22, we can also join copper to aluminum with that same rod. Because in any system, you're going to have a transition joint because you're going to be brazing out in the field to the copper here.
On installation, sure, absolutely.
If the leak appears onto that copper to aluminum joint, the same thing, the same rod can be used. The only difference is when you're applying the heat goes onto the copper and let that transfer to the aluminum.
That makes sense.
And then touch. If you heated opposite, if you heated the aluminum trying to transfer to the copper, the aluminum would melt before the copper would get to 900 degrees. So you'd have a failure. So again, concentrate the heat onto the copper, let it transfer, and then touch with the rod. And as it begins to flow, pull the heat back again, just like it would be for an aluminum coil.
Man, yeah, I'm wishing I would have been a little bit more prepared for that. I was trying to think if I had any 3/8 copper flared stubs that I could have brazed onto this, but I don't have it at the minute.
If you'd like, I can do one here.
I would love for you to. Absolutely. Yeah, Jason, thanks, man. And we really appreciate you joining us. This is what we do every single Thursday. We try to take things that need to be understood better in the industry, and we bring in the top educators. Bob's not called Bob the Brazer for no reason. Bob, how many years have you been in the industry?
Oh, boy. I worked in the field for 35 years, and then when I retired, I went to work for Lucas-Milhaupt. They found me by accident out there, unbeknownst to me as well at the time. But so I've been working with Lucas for 13 years. So what's 35 plus 13 is?
Wow.
48.
All right. So been in the industry for a while.
Right.
How comfortable were you when you first started working with aluminum?
Well, I probably had the same apprehension that most people have. But I was fortunate to be surrounded by truly experts and metallurgists.
Right.
They actually designed this alloy and knew how it worked. So within minutes, they showed me what it can do. And then fortunately, I have pretty natural ability to braze because I did a great deal of it with my experience. But once I realized the key is understanding the material, the aluminum, its melting point, and then understanding the rod itself. So now I know the difference is the 300 degrees. And the other key is not looking. A lot of people want to look for a temperature change, but you're not going to see that in the application. And you won't see it even at the copper to aluminum. We're not going to be looking for any cherry red to the copper here, because at cherry red, the aluminum would be destroyed and gone already.
Exactly.
So I've set up here. I've got basically a swedged piece of copper, sliding the aluminum into it. And I'll relight my torch here. Okay. Again, same flame. With the oxy setting, I like to see a bit more of a feather in there.
Yes.
Soft flame. The advantage of that flame is that it's wider and softer, and it will engulf the fitting better than it would be if it's a small, concise.
Oh, yeah, absolutely. Makes sense.
So again, when you can, especially in this position, you like to keep the torch perpendicular so that the flame will wrap. Okay? So what you'll notice once I get it up to temperature here is that there'll be very little movement of my torch or the rod itself. So I'm going to start touching here. Here it's flowing right now. You swing it around a little bit to this side. Noticing I'm keeping majority of that heat onto the copper.
Yep. Pulled right in.
And I'm done.
No.
Simple as that.
You got to be kidding me. And that's what is that 3/4?
This is a half-inch tube.
Half inch. Okay. Huh.
Again, I'll let that cool. Wet rag, clean it, because you'll see you'll see kind of a white powdery surface of it, and that's the cesium powdered flux that's in the rod.
And I can show that a little bit too. I'll grab my cleaning rod and bring up a better picture of that so we can see, because I haven't cleaned any of mine yet. So if I bring that back in where you can see that. So what we're talking about is right just on the surface.
Right. And even a wet rag is fine too.
Okay. So once that's cleaned off, boy, it's just looks like the regular raw aluminum underneath of it.
Then you do a pressure test to ensure that the joint is sound. And away you go.
Off you go. Wow. All right. So that really clarifies a lot, cleans up a lot of the stigmas that I personally had. And no, Jimmy, that's all right. So this is a really good conversation to have, Jimmy. So Bob is using a traditional oxygen acetylene torch set. I can actually pull it up for you all to see. I grabbed a picture of that earlier. Should be able to bring this up. I am using what I've just recently been experimenting with just because I wanted to have one here. I am using one of these little mini torches with plain Jane MAP gas and oxygen tanks that I got from my local Ace Hardware. So I'd ordered the mini torch set online. I know there's a couple other manufacturers out there that make mini torch sets. And I'm using, let me pull these others out so you can see. I'm using the AL822. I had the Silphos 15 just in case I did any copper to copper, but I'm so intrigued with this that I didn't even want to get to the copper side of things. We were going to talk about some copper principles if we needed to, but no, this is really, really a good conversation on aluminum. So it's literally MAP gas and oxygen with 822 on my side, and on Bob's side, he's using oxygen acetylene in 822.
We can also use aerosol in the aluminum application. You can use straight MAP, or you could use straight propane. Again, you don't need a great deal of heat.
No.
But the approach would be the same. We'll continually touch with the rod, and that will tell us where we're at.
Okay.
No matter what.
Yeah. Is there any questions out there? This is a great time to step back and talk about anything. Remember, we are here for you. We do this every week because we are educators. And one thing you'll find about most educators, we all really are just servants. We have servant hearts, and our goal is, and our enjoyment is, to give back to our community. You are our community, and we're here to serve you. So any questions that you have, now is a really, really, really good time for that. Absolutely, Jimmy. And those that want to learn more about Lucas, before I get too far into that, I'm going to throw up some extra QR codes. So there's actually resources for learning more about this, isn't there, Bob? Over at, let me grab the right contact for that, over at the Brazing Academy.
Yeah, just go to Lucas-Milhaupt.com. They'll go to our website, and from there you can go to anything you need. Identifying alloys, how to use the alloys. We have videos there. If you purchase the AL822, what you'll see is a QR code on the tube, and you can scan that with your phone, and it'll take you to a quick 2-minute video on how to braze aluminum and copper to aluminum.
Oh, fantastic.
So if you get this or need a refresher, you can go to the website or just click on the QR code right on the tube itself.
Fantastic. And for those that are looking for additional training resources when we're talking about brazing, we also at ESCO have a brazing and soldering that gets more into the principles, all the foundational items that we need to. Then when we get into the specific, well, that's what we're here for today, is to really dive into the specifics of using alternative rods and materials. And yeah, with straight MAP gas. All right, Todd, it's on. You and I, one of us are going to have to do this.
Yes, though, if you have the ability to find yourself an old aluminum coil, most of you probably are in a position to get that. Buy yourself a tube. It comes in a tube like this, 4 sticks, and practice. It's punch some holes in that coil and make some repairs. I wouldn't want to suggest that, sometimes it would happen, but make your first attempt to be somewhat controlled in environment, because your failure is fine if it's in a situation like that. You don't want that failure to occur out in the field. Okay, no. So if you have a chance, try to practice a little bit ahead of time. I think you'll quickly, by the time you go through maybe just a couple of inches of this rod, because it doesn't take much to make a repair, you'll be very comfortable.
So we did all of that, and I still have 90% of my rod left.
Exactly.
Yeah. And I promise all of you, I did experiment with my torch today, but I promise I did not use the rod. We took the rod out of the package at the beginning of the show, and that was the first rod that I have used. So there were 4 successful attempts for the first time that I have touched aluminum in probably 3 years. And I wasn't comfortable with myself, so I never continued working with aluminum. Yeah, I just came back. So, Todd, I just came back from my local Johnstone supply where I picked up that coil off from their damaged pile, and I picked me up some of the Lucas AL 822 sitting right there on the shelf. They had just as much of it as they had the Silfos 15.
Johnstone supply carries it.
Absolutely. Yeah, very, very common rod. Okay. Any questions out there from anybody? Any things that we need to go over further, Bob? Anything like that Silvalloy 450? Anything we need to talk about with it while you got it out?
Well, what we have, if we're looking at the 450 comes in 3 different versions. Basically, what it comes to is the flux, what we call the flux coated rod.
Yep.
We also have that version in what we call the flux cord rod. So we have a version of that, and then we have the old tried and true, where you have the bare alloy here.
Yes.
With the bottled flux. Okay. Keep in mind, all 3 of these basically are all the same rod. The alloys is the same. It's just how do you want to apply the flux, either from the bottle, from outside the rod, or from inside the rod. So you basically have choices there. And in most cases, people are tending to go to the flux cord rod. You saw the advantages of with the aluminum. Same thing in a copper to steel application. You have that same advantage with the flux cord rod there as well.
Yeah. And so I had personally used the Silvalloy before, and I'm wondering if that may have been my scenario, is that I was trying to find the right combination of flux and rod, or flux and alloy, and then wasn't able to. What's the minimum maximum heat range for brazing aluminum? We kind of covered that earlier. Would you like to kind of recap on that real quick, Bob, for us for a little?
The melting point of the aluminum itself is 1218 degrees, and the melting point of the rod, the AL822, is 900. So again, the key is to heat the surface and touch the rod, and when the rod flows, now you're at 900 degrees, pull the heat back.
Yeah.
Because quickly, no matter what torch you have, you can go from 900 to 1200 and then destroy the aluminum.
Absolutely. So it's a matter of just getting used to not keeping that cone as close to the materials we're used to with copper. And, this is the reason we do this, Jamie. Thank you so much. This is a great, great point. Typically we would replace coils, but if you've got a problem with it, why not give it a try? I mean, what's going to hurt?
Such that you can't get a coil immediately or quickly enough, you can still make the repair and get the customer up and running, and then come back at a later date and replace the coil. If you may find you don't have to replace the coil.
Yeah, you may have succeeded. I'm very confident in the repairs that we just now made. Question came in from Todd. Would it hurt to use flux and the 822 with the core? I would tell you, Todd, that from what I've just seen, wouldn't be necessary, but
is the question, the only flux that the aluminum alloy has is what's inside this rod. It's
right.
Not the same flux that you'd see here.
This good point.
Be applied to this.
Okay.
The flux, the brazing flux, is set up for a much higher melting point to activate.
Ah,
we have with aluminum.
gotcha.
The
Another.
is what's in the rod with the aluminum or aluminum to copper application.
So now that we've successfully done copper and copper to aluminum and aluminum repair, is there anything available for stainless steel?
Yes, in a stainless steel application, copper to stainless steel, we'll be looking at what we call the Silverloy 505. Okay, and we make this in the flux cord, flux coated, or in this version as well. Again, so but you'd want to go with the 50% version because in this case we'd have additional tin in this alloy, which protects us from corrosion when stainless steel is present.
Okay.
So one of the three versions, but you want it to be the 50% with stainless.
Okay. Question came in, Mr. Tebby, missed the very first part. What was the surface prep? Stainless steel wire brush.
Stainless steel wire brush.
That's it. There was no special prep needed. It was literally clean and go, just like we were working on copper.
Right. The key is always a clean.
Yeah.
You
Yeah.
want
Better.
the alloy will attach to the material itself, but not if there's dirt present.
Okay.
And that's the case for copper as well.
Absolutely. I'm sold. I feel comfortable and confident to repair aluminum. Imagine that.
That's what we're doing.
Yeah. So why don't we do it in our classroom? Sounds like the next opportunity, isn't it?
I think so. If you're instructors out there or whoever you are, again, avail yourself to the products that are out there and your ability to learn how to use them. So again, in this case here, you see the learning curve is not that great here, and we don't take years of experience to learn how to braze.
Yeah.
Something that can be done relatively quickly.
Yeah, I was impressed
as well, especially with a new product like aluminum.
Yeah, in almost every coil that I have seen now being manufactured, at least for residential split and for ductless, have gone to aluminum.
Aluminum has been in the market for a long time. In the supermarket industry, a lot of deli coils and many coils were aluminum even 30 years ago. But 30 years ago, we didn't have the AL822. What we had to use was epoxy.
Yes, exactly.
Coil. Epoxy is a very iffy situation.
I've never had success.
Exactly.
I know you're supposed to, but I never had success with epoxy.
I would never be confident or comfortable with using epoxy.
No, I wouldn't else. All right. Any additional things that you think we need to cover?
No. Again, I think utilize our website for additional information. Use the video that we have, like using the QR code. If you need additional, little refresher there, I think that avail yourself. If you have an opportunity, I do these classes all over the country. It's much more involved than what you see tonight.
Mm-hmm.
We just focus on the aluminum.
Yep.
But if we go into the copper applications, we go through what we call our 6 fundamentals, 6-step procedure. When properly done, will ensure a sound braze joint. And then we go into the dissimilar metals where we talked about copper to brass, steel, stainless steel.
Mm-hmm.
And then the old tried too, using the 15% for copper to copper applications.
Excellent.
Like that.
I see a lot of people getting anxious to go out here and play with some aluminum coils. I'm telling you, go do it. You'll be surprised.
You will. And keep in mind too, when that joint is done and done soundly, that joint or the repair is stronger than the base metal you connect it to. A lot of people always ask about pressure test. Well, the pressure test is good to 2,500 psi. And what happens at 2,500 psi is that the aluminum or the copper would rupture, but the joint is intact. Because when the joint is done properly, it's stronger than the metal you connect it to. Again, people can't expect anything more than that. And there's no system that operates anywhere near 2,500 psi.
No, not unless you're tinkering with CO2, which we're not going to be using aluminum on anyhow.
No, but CO2 is even 1,000 psi.
Yeah.
So a copper joint is still well,
Institutional.
well stronger than it need to be.
Yeah, we use copper in a lot of our CO2 systems. Okay, well, I think that's a wrap. I really appreciate this. Like, really, really appreciate this, Bob.
Oh, you're welcome. You're welcome.
Yeah, you're right, Thomasina. This is as good as it gets. All right, so I encourage everyone to reach out. You can find Bob probably on LinkedIn. You can find Lucas-Milhaupt on LinkedIn. You can go to the website. All of these videos that we do are available every week to come back and recheck on all these social media feeds that you're joining from today. You can go over to our e-learning course. And if you're looking for CEUs or CEHs, you can actually go to the HVACR Learning Network, go back through and take an assessment, and you can actually get credits for CEU or CEH for these and print out a certificate. So I encourage all of you to do that and tell all of your friends where you learn how to braze aluminum. All right. Well, I will see you all again next week on Did You Know, the ESCO HVAC Show. And Lucas-Milhaupt and Bob the Brazer, we are so grateful for you.
Thank you for your time today.
We'll see you again later.